So how do we go about creating a matrix in R? Well, it's actually pretty straightforward. To create a matrix in R, you want to pass a vector to the matrix function and specify the number of rows and columns the matrix is going to have. There are actually default values for the number of rows and columns, but it's better to specify those because you probably know how big the matrix is going to be ahead of time. So the values of the vector you pass to the matrix function are going to be placed into the matrix one column at a time. So we fill in the first column, and then the second column, and then the third column, etc. The in-row argument is going to indicate the number of rows that the matrix is going to have, while the in-call argument is going to specify the number of columns that are in the matrix. So let's create a 5 by 2 matrix with the elements 1, 2, 3, 4, 5 in the first column, and 6, 7, 8, 9, 10 in the second column. So really this is just the vector 1, 2, 3, 4, 5 all the way up to 10. And we want to pass the first 5 elements into the first column of A, and then the second 5 elements into the second column of A. So I'm going to do that down here. So I use my matrix function. I give it the values 1 through 10. I specify that I want 5 rows, and then I want 2 columns. And so I'm going to run this in Colab here. And we can see that we get a 5 by 2 matrix of integer values, where the first column is the values 1 through 5, and the second column is the values 6 through 10. So we did in fact get exactly what we expected. However, you might say to yourself, well, I really don't want to add the elements of my matrix column by column, but instead I want to do it row by row. Well, you're in luck. There is another argument that you can specify in the matrix function called the by row argument. By default, this is false. But if you specify by row equals true, then it's going to fill the elements of our matrix in one row at a time, starting with the first row, then the second row, etc., until the matrix is filled out. So in the second example, I'm going to create a matrix with the values 1 through 6 that has 2 rows and 3 columns that fills the values of the matrix by rows. So I run that, and you can see here we have 1, 2, 3 filling out the first row. And then once we fill that row, we go down to the next 3 elements, 4, 5, 6, that are going to fill out the second row. So that's one way to create a matrix directly. Sometimes we want to manually create a matrix using the cbind or rbind function. Cbind stands for column bind, and rbind stands for row bind. And this is a way of taking matrices or vectors really and combining them together by columns or rows as desired. So in the example below, we combine the vectors 1, 2, 3, 4 and 5, 6, 7, 8 column-wise to create a matrix. So you can say I have the vector 1, 4, so 1, 2, 3, 4. I have the vector 5, 6, 7, and 8. And because I use the cbind function, I'm going to take this vector and combine it column by column with this second vector here. And you can actually have more than 2 columns if you want. You could add 3, 4, 5, whatever. But usually you don't want to do this for too many columns. So when you run that, we can see that we get 1, 2, 3, 4 in the first column, and then 5, 6, 7, 8 in the second column, which is what we expect. Next, if we want to use the row bind function, we can do the same thing, but instead of getting a 4 by 2 matrix, if we pass in the vectors 1 through 4 and then 5 through 8, and we use rbind, we're going to get a matrix of size 2 by 4, 2 rows and 4 columns, where the first row of the matrix is 1, 2, 3, 4, and the second row is going to be 5, 6, 7, 8. And if you have a matrix, and maybe perhaps you read it in from a file or something like that, or it's just given to you, and you want to know how big it is, then you can use the dim function. So in this case, we're looking at the dimensions of A, and that was what we specified up here. We know it's a 5 by 2 matrix, but if we didn't know that, this tells us that the first dimension of A has 5 rows, and the second dimension has 2 columns. And this is actually a more general function that you can apply to arrays and things like that, which we'll talk about later in this chapter. But this is an easy way of determining the dimensions of the matrix. 2 additional functions that we should know about when we're dealing with matrices are the in-row and in-call functions. And these functions are used to determine the number of rows and the number of columns, respectively, in a matrix object. So if we use the inRow function on our matrix A, we know that it has 5 rows, and that's what we get. And if we want to see the number of columns, we know it should have 2 columns. When we run the incol function on A, we once again get 2. So the dim, inRow, and incol functions are all very useful for determining the dimensions of a matrix that's already in R's memory.